So I just want to introduce myself. I am Ayushman. I am currently studying BTech from IIT Kharagpur. So I'm just starting to make videos regarding math about some concepts of JEE mains tough questions and just for JEE Advanced too. So this is my first video that is regarding gamma and beta function. So I just take this topic because we know all this is the ending part of November and starting of December. So in every coaching centers we just have completed integrations, and many students face problems in integrations and doing the tough questions also. So this beta and gamma functions gives us a bit easier method to solve the lengthy questions of integration. So I just want to start with gamma function and then move on to beta functions in the next video. So what is a gamma function? What is gamma functions really means? So gamma functions is like we represent gamma function as like this. This is the representation. So what does this means? So it does not means complicated, it's just easy. This is gamma of n means n minus 1 factorial. It's easy. We all know that what's factorial is, like 2 factorial it's 2 into 1 is 2, 3 factorial is 3 into 2 into 1, that is 6, and we know that n minus 1 factorial will be like n minus 1 into n minus 2 all the way up to 1. So we all know what factorial is. So gamma of n is equals to n minus 1 factorial. So now we want to know how we integrate gamma function into integration. So we must have seen questions like from 0 to infinite x to the power n minus 1 e to the power minus x dx. This is the general method of gamma function. This is equals to gamma of n. So I'm just taking an example, just like from 0 to infinite x to the power 4 e to the power minus x dx. So you may have seen these questions or you may not have. This questions is like a bit of JEE mains tough side or advanced. It's just basic, but this modifications may come in JEE mains or JEE advanced. So we may have seen this type of questions, and many of you may not be familiar with 0 to infinite. We solve this type of difficult questions at the end of integration. So the limits like does not rules from minus 2 to 2 or from 0 to a, like that. It goes from 0 to infinite. So we don't apply here kings or like different methods to solve this type of questions. We don't know how to solve this. We just do by like, we know the by parts integration, we just apply by part and it makes it longer and longer. So there is a easy way of doing this, we all know that. So we studied that gamma function is like 0 to infinite x to the power n minus 1 e to the power minus x dx equals to gamma of n. So this we can write this as f of n. It's a function of n. It does not depends on x. So x is a parameter, so we can change it for x, we can change it for t, we can change it for y. So like that, it's f of 5 equals to from 0 to infinite x to the power 4 e to the power minus dx. That's equals to gamma of 5, that is 4 factorial. So in just shorthand we can remember that what's the power is here, we just get the factorial of that only. As simple as that. Or plus 1 gamma. It's like 4 is there plus 1 5 gamma function of 5. So this is the whole part of gamma, but we know there is variations in this. Like I'm just taking a simple variation of 0 to infinite x to the power n minus 1 e to the power minus x dx. So we can just remember the formula as gamma of n to the power a of n, or we can know a simple trick that we can apply to any questions that comes in like this format. So if e to the power minus any function is there, let's just say here it's a to the power x. So we just have to assume a to the power x equals to t. So x becomes t by a, and a dx equals to dt, so dx equals to dt by a. And here also, if sorry, if x belongs to 0, then t also goes to 0, and x goes to infinite, then t goes to also infinite. So the limit does not changes, so the limit remains same, and it's become t by a to the power n minus 1 e to the power minus t dt by a. So this just changed into t to the power 1 by a to the power n, it's the denominator, and this becomes t to the power n minus 1 e to the power minus t dt. So what's this? It's just we have changed the parameter of x to t. So it same remains gamma of n by a to the power n. So we just changed x to t. So it does not change. As I told earlier, x is a parameter. We can change it to y, we can change it to t. So it's eventually this whole becomes gamma of n. So the final results came as like this also. We know a well-known integration, that is the Gaussian integral. So Gaussian integral is like minus infinity to infinite e to the power minus x square dx equals to root pi. So we can prove this using gamma function. So in my J time, I don't know how to prove this Gaussian integral. I used to watch videos in YouTube, and it shows a very lengthier process of proving this. But using gamma function, we can solve this Gaussian integral within seconds. It's like we just have to substitute x square equals to t, substitute x square equals to t. So it becomes 2x dx equals to dt, dx equals to dt by 2 root t, because x equals to root t. So we just convert, and it's like e to the power minus t dt this, and it goes from x minus squares to, so here we can write this as 0 to infinite 2 times, because it's an even function. So as what's there in the left side, it's symmetric about y-axis. So here e to the power minus x square is symmetric about y-axis. So we can just make it 2 times of 0 to infinite of e to the power minus x square dx equals to root pi, and 0 to infinite e to the power minus x square dx equals to root pi by 2. So it seems familiar, because we know in gamma function we take it from 0 to infinite. So it's now the limits are familiar. Now we can also put like 0, x equals to 0, t equals to 0, x equals to infinite, t equals to infinite. So now it becomes like t to the power minus half e to the power minus t dt integral 0 to infinite 1 by t 2. So we just have to remember one fact in gamma function, is that the gamma function of 1 by 2 is root pi. We can prove this by integration, but there is no need of deriving this whole proof of gamma of 1 by 2, because we don't need it for J. We can just simply remember gamma of 1 by 2 is equals to root pi. It is very helpful when we will see questions of JEE mains and JEE advanced of beta function, and we can solve that using gamma of 1 by 2. The gamma of 1 by 2 will be at the end of the solving the whole part, and we get upon gamma of 1 by 2 in there also. So we can just remember this gamma of 1 by 2 equals to root pi, and we can see this, it's like here 1 by 2 into 0 to the power 0 to infinite t minus 1 by 2 e to the power minus t dt. So this gives us gamma of 1 by 2 by 1 by 2. So this is root pi by 2. We simply got this. We just proved the Gaussian integral using gamma function. So gamma functions helps us to minimize the length of the problem solving time. It's also minimize the time of solving the problem. So this is a very, and we will learn how gamma function is very useful in beta function. Without the knowledge of gamma function, we can't read beta function, And in beta functions we have a lot of PYQs of JEE Mains and JEE Advanced of beta functions. So the formula, I have given you all the formulas. There is another one formula that you may learn, is like gamma of n plus 1 equals to n of gamma of n. So this is basic n factorial equals to n into n minus 1 factorial. We know that this we can prove through integration only. So there is no need in JEE, so I'm not going to derive it. So how this is helpful in some beta function, we will study it's may something like 7 by 2 gamma may arrive. So how to solve this 7 by 2 gamma? We only know gamma of 1 by 2. So we can use this formula to simplify it to gamma of 1 by 2. Just like 7 by 2 into so 5 by 2 into 5 by 2 gamma of 5 by 2, 5 by 2 into 3 by 2 into gamma of 3 by 2, 5 by 2 into 3 by 2 into 1 by 2 gamma of 1 by 2. So it's bring us like 15 root pi by 8. This is the value of gamma 7 by 2. So we use a lot in beta function. So I am studying the gamma function first to get us a very overall knowledge about gamma function. Then we will read the beta function and solve a lot of PYQs regarding that. Now this is all. So I just want to summarize all the things that I have told in this video. So the first formula that we know is like that I taught is like gamma of n is equals to n minus 1 factorial. This is very pretty, we all know that. Then we just come like gamma of n plus 1 is n into gamma of n. Then the third thing that we learn about the integration that we learned is like 0 to infinite x to the power n minus 1 e to the power minus x dx equals to gamma of n. Then for solving general equations, like we may get of x to the power, here we can get any q of x, but this should be like a single unit. Like we can't, if it's a polynomial x cube plus 3x square plus 2x plus 1, it's like a cubic equation. We can solve this too. To the power any f of x dx 0 to infinite, we can solve this too very easily, just like 0 to infinite x cube e to the power minus fx dx plus 3 into 0 to infinite x square e to the power minus fx dx. We can just break down into small parts and we can solve them individually. So it's more like that only. If we give any polynomial, we can solve like this. We just have to break down it into small parts, and then we can solve each parts to get the solution. So here the simple step is like f of x should be substituted to t, then f dash dx equals to dt, and then we simply got e to the power minus dt, and we have to solve the whole equation regarding this only. So it's a very simple step here. We can of course we can learn this, we can remember this. So this is all about the gamma functions. I may attach a PDF to solve questions of gamma function, so that you can get habituated to gamma function, so that we can easily learn beta function. So there is a PDF given below in the description where you can check out the problems of gamma function. You can just try that out. After that you can see the beta function, where we will do a lot of PYQs of JEE Mains and JEE Advanced. So this is my first video that's about gamma function. I will make a lot of videos about the small topics that are very important in JEE Mains and JEE Advanced. So if you like the video, you can show some love in the comments, and that's all. Thank you.